Okay, now can you hear me? Okay, I think this now the settings was the microphone is off. You now can hear me? Okay, hopefully now you all can hear me because I just changed the setting. Okay, so start again. Welcome Form 5 students. Okay, how are y'all? So today's topic we are actually going to topic 5, probability distribution. All right. So before we get started, uh, just help teacher to share the live classes link to your Facebook, YouTube, or WhatsApp status so that more students can know and they can join also. Okay, now can hear me? Like, I think it's okay already. Okay, right. We should start with the first part, 5.1. So today we're going to focus on 5.1, which is random variable. Okay, yeah. Under random variable, we're going to learn two types, which is discrete and continuous. Okay, so first of all, uh, what is random variable and why you are learning this chapter? Okay, so this chapter is all about probability. Like, for example, let's say if today teacher play a game, okay, usually games you have the dice, isn't it? Like you have number 1, 2, 3, 4, 5, 6. So what is the probability that teacher get number 5 from the dice? So those are the things that you learn in this chapter. Okay, you use probability to find the outcome. So under this probability, usually there will be two types of calculation. Okay, one of the calculation is known as discrete random variable. The other one is known as continuous. Okay, but before that, okay, let me write down first what is random variable so that you guys can also copy down in your notes. Okay, all right, random variable. Now, okay, the quantity. Okay, this is write down first. Quantity depends on random outcome. Okay. Then the other one, the domain is the sample space. Sample space, which we usually use as. And for the range, usually will be the x will be the range of sample space. Okay. Now, what does this mean? Okay, first of all, when you see any experiment or anything that you do to find the probability, okay, you will usually get like an outcome, correct or not? Like for example, let's say today is going to snow. Okay, for example, today is going to snow. So you have two options. Either it will snow or it will not snow, correct? So like got two options there, right? So that is called your outcome. Alright, that is called as outcome. Apa yang akan berlaku, like that. So you need to know the outcome. Okay. So in this case, uh, for random, okay, random is like anything can be the outcome. We're not sure. Okay, it's just random. The sample space here means is that, okay, sample space is like what options you have. Okay, we have the option of today is going to snow, today is not going to snow. So those are called also your options, sample space, which we categorize that under domain. Okay, maybe snow I think wouldn't be a good example. Teacher used like dice. Okay, dice total got how many numbers? Total got 6, right? 1, 2, 3, 4, 5, and 6. Okay, but let's say when teacher roll the dice, I want even numbers. So even numbers means is only either 2, 4, or 6. So the 2, 4, and 6 are known as my outcome. That means like what I want. Okay. The 1, 2, 3, 4, 5, 6 is known as my sample space. So like what is the total of all the outcome that can come out as, okay? So that's the sample space. And usually that one will go under domain. If you all still remember, okay, domain, right? Domain and range, okay? We follow the graph, domain is the x and then the range is the y, like that. All right. Okay, next one. Let's look at, okay, discrete and continuous random variable. Okay, the word here discrete. Okay, discrete means you can actually count. Okay, that is the meaning of discrete. It's countable. Boleh dikira. So like for example, okay, so right here example, you can count coins, not coin, not count how many coins, like how many times, if let's say we toss a coin, kita how to say, we lambung the coins, okay, you can either get a head or you can either get a tail, correct? Okay, so that one you can count, okay. And usually for discrete we will use tree diagram. Why? Because most of the times you will have like two options of answer, head or tails, like that. Rain or don't rain. Maybe it's a boy or a girl. So this we will use tree diagram. Tree diagram is very important for this topic. So that one you have to master how to draw the tree diagram. Okay, the next one, continuous random variable. Okay, this one usually you will have the data with many values. There will be a lot of values and usually it's used, like for example, if school means we will calculate the height of students, maybe like the weight of students, okay, the pressure, okay, pressure reading, something like that. That one is known as continuous random variable. That means let's say teacher want to find probability of students with the weight of 50 kilograms. So for so many values, right, of students with different, so you will get different outcomes. So in that case, that is known as continuous random variable. So you won't get like specifically only two answers like that. You'll have a lot. Okay, so for now, these are the two things you must be able to differentiate. Discrete means you can count. Okay, like it snows or don't snow. Head means, coins means got head and tails. Okay, continuous means you will have a lot of values for the data. Okay, now let's look at the first question. Okay, example one. Okay, consider a coin is tossed 3 times. Okay, a coin is tossed 3 times and all the possible outcomes are recorded. The random variable x represents the number of heads obtained in the 3 tosses. Okay, find the range. Okay, find the range of x in the set notation. Okay, set notation, you all know set notation. We learned already. Set notation in maths, you must use like with the curly bracket. Okay, okay. So, okay. First of all, let's write down. Okay, here x is representing what? We know x is representing number of hits. Okay, number of hits. So for heads, we are going to use the letter, capital letter H. So you just write down first. H is heads. T is we use for tails. Okay, H is head, T is tails. Now, we are going to throw the coins 3 times, isn't it? 3 times. So if you throw the coins 3 times, okay, what sample space can come out? That means what outcomes can come out? Okay, let's see. Sample space S. So that means I'm going to write what values all can happen. So in order to write the values, okay, we can do a tree diagram. Okay, see how teacher do the tree diagram. Okay, so the first toss, okay, first toss. Okay, what can outcome can happen? We can have a head or we can have the tail. Okay, heads or tail. Okay, second toss. Second toss. Here we can have a head, we can have a tail. Okay, for the bottom also, either we can have a head or we can have a tail. Okay, so it's like this. The first toss, maybe head come out first, then tails. Okay, for the second one, maybe you do for the up first. Maybe head come out first, then tail. For the bottom also, maybe head come out first or tail. Right? Okay, next one. Go for third toss. Okay, the third toss, let's do for this first. Okay, this one either heads come out or tails. Okay, for this also we need to expand the three branches here, head or tail. Okay, and this one also maybe head or maybe tail. And the last one, head, tail. So basically, if you can see, it's like branch, isn't it? You open up the branch, okay. And all the branch got only like, all the opening got two branches only. So therefore now, sample space you can write here usually at the end. Okay, sample space. So what you do, you just start with this. Okay, this is H, H, H. So the first one, okay, the first one, we just write H, H, H. Okay. Now for the second one, H, H, T. So we copy that one. H, H, T. The third one, H, T, H. So we write H, T, H. The fourth one, H, T, T. Okay, so H, T, T. Fifth one, T, H, H. Okay, so T, H, H. T, H, T. T, H, T. T, T, H. Okay, T, T, H. Alright, T, T, T. Okay, T, T, and T. Okay, so far, oh, yes, can say so also. It's like your maths form 4. Yeah, because you have to list that probability, right? Back then you all learned this. Network in graph. Network in graph got vertices like that, right? Uh, but if you tell teacher like I think maths form 4 chapter 7 probability, that one also you all got learn like this. Okay. Okay, so now once you list down already the sample space, okay, you can straight away see here. Okay, so now what will be our, so the sample space you don't have to write all one by one. Okay, teacher is not going to, because we already did that, right? So I'm not going to copy one by one. Okay, so here what we do now, we can write the x represents the number of heads obtained in 3 tosses. Okay, how many heads has been obtained? Okay, now let's calculate now. Okay, let's calculate what is our x. Okay, so we write here x. Okay, here got how many heads? We have 3 heads. Okay, here got 2 heads, 2 heads, 1, 2, 1, 1, 0. Okay, so this is consider your range, because here they already told you find the range of x. Okay, find the range, meaning that x is representing number of heads. So total here, number of heads we have starting from 0. 0 is the lowest, the highest is 3, isn't it? So therefore, when we write our answer, okay, what is x? X is equal to, okay, put x equal to, because you have to write in set notation, put curly bracket. Okay, so 0, 1, 2, and 3. So this is the range, meaning that the head got 0 times, the head got 1 time, the heads got 2 times, the heads got 3 times. So you got the range of the value of number there. Okay. Okay. Clear for using tree diagram. Okay. we go to next question, example 2. Okay. All right, let's look at example 2. Okay. There are 3 sweets and 4 packets of biscuits in a box. Okay. So there's a box, got 3 sweets, got 4 packets. An item is taken out at random from the box and it's returned to the box before the next item is drawn out of the box. Okay, the process is repeated twice. So they do this 2 times. Okay. The random variable x represents the number of times a sweet is taken out from the box. List all the possible values of x. Okay, now we have how many sweets here? 3 sweets, okay, and 4 biscuits, and each time they take out, okay, they like, for example, teacher take out sweets ready means out ready means, okay. The next one, when teacher is taking out, I put back the sweet in, then only I choose back the sweets or biscuit. Okay, so I am actually putting back the items in. Okay, so when you see like this, okay, this is random, discrete, random variable. Why discrete? Because you can count. You got 3 sweets, you got 4 biscuits only. What? It's like not like a lot of sweets, a lot of biscuits like that to calculate, isn't it? Okay, so we can also use tree diagram here. Okay, how to use the tree diagram? Okay, let's see. First, let's identify. Okay, we use S for sweets, and we use B for biscuits. Okay, now let's look at this one. What happened? Okay, first they are taking out. Okay, so if they are first taking out, like you are going to do the first item, we taking out. Okay, so can either come out sweet or can come out biscuits. Okay, correct? Okay, how many times they did this? They repeat this process 2 times. So that means this is the first time. Okay, second time. Okay, let's see. Second time, what can item can come out? Okay, sweet can come out. Biscuits also can come out again. For the bottom one, same. Sweets can come out. Biscuits can come out for the bottom one. Okay. The moment you do all this ready, immediately the last place, right, you write the sample space. Okay, so in this case, the first one is SS, SB, BS, and BB. Okay, so we just write down all the sample space. Okay, then what is the X that they actually ask us to find? What is X actually? X represents the number of times a sweet is taken out. Okay, so you know already X, X is how many number of sweets. Okay, so now let's see here for the first one, SS. So we got two sweets. Okay, SB, 1 sweet. BS, 1 sweet. BB, 0 sweet. So what are the possible values of X? So X can be 0 sweets, can be 1 sweet, 2 sweets, or 2 only, sorry. 0, 1 and 2. Stop at 2. Okay, clear? Because the moment you can do your tree diagram well, you can always get the answer easy and correctly. So you don't have to list down, like some um teaching, like the teachers teach just like list down everything, sweet biscuit, then like you get confused, how many times should I list? So it's better to use tree diagram. Okay. Okay, Yeah, I give you all a few seconds to copy down. Then we will go to next question. Okay, let's go to question 3. Okay, determine whether the following cases is discrete random variable or continuous random variable. Explain your answers, hence represent the random variable in set notation. Okay, the first one. The random variable x represents the height. Okay, this one teacher gave you all the clue just now, the example continuous, isn't it? Height of, okay. Heights of Form 5 students that are more than 150 cm. Okay, so for A, what is our x actually? X is representing the, x is continuous. Okay, first we know this is continuous random variable. Okay, why we know this is continuous? Because you explain, because the height can be more than the height can be more than 150, isn't it? They want more than 150. So more than 150 means like what kind of values? 151, 52, 53, like all the way inward until 200, we don't know. Okay, so therefore when you write your set notation, okay, so x is equals to, okay, x you put the double dot. Okay, this is set notation. So x is bigger than and equals to 150 cm. So you use the, this one we learned when we were form 4 for sets. We learned for sets how to write the set notation. Okay, B. The random variable x represents the number of times getting the number 5 when a dice is tossed 10 times. Okay, so this one you know for sure they are going to do 10 times only. So you got 10 outcomes only. You won't have like a lot of outcomes. We don't know like uncountable outcomes. Tak ada. So it's like just the outcome 10 times. Okay, so this will be automatically discrete random variable. So x is discrete random variable. Okay, why? Okay, we explain, because they asked us to explain, isn't it? What's the reason we say the number of, okay, we want to get number 5, isn't it? The number of getting 5, okay, is countable. We can count what? Okay, because it's counted 10 times only we want to count. Okay, it's countable. So therefore we know how it works lah. Okay, so how to write the set notation? Okay, x equals to curly bracket x double dot. Okay, so the number 5 can be 0 times, 1 time can happen, 2 times, 3 times, 4 times, all the way until 10 times, right? So 0, put the x in the middle, and until 10 times. So it can happen from 0 to 10. What it means is can happen 0 times or can happen 10 times also. Number 5 coming out after you roll the dice. Okay. The only thing that you have to master here, which is like how to write down properly. Okay, because other than that I think you all can understand, but sometimes the writing part only you get confused. Okay, let's look at next one, table and graph. Okay, give you all a few seconds here. Okay, Okay, next one. Table and graph forms. Okay, this one is interesting because you already will have like a way or a format like that for you to do. So you just have to follow the format like that, so you don't get confused easily. Okay, just apply based on the format only. Okay, let's look at the first one up. Okay. Mm, a dice is tossed twice. Okay. X represents the number of times getting number 2. Okay. Draw a tree diagram to show all the possible outcomes. Okay. Can we do this together? Okay. Drawing a tree diagram. Okay. Let's start with here. Okay. A. Tree diagram. So we know the X is for what? X represents getting number 2. So our focus is X is to get number 2. Okay. Now, how many times the toss happened? 2 times. Okay. So it's the given here already. You can highlight that happened 2 times. Okay. So we start. Okay. So first time. Okay. Right here. This is the first time. So what values can happen, we want, because your goal is to get number 2, right? Okay, so maybe can get number 2 or you don't get number 2. So if you don't get number 2, you write as 2 prime. Okay, meaning that you get number 2 or you don't get number 2. So you write 2 prime. 2 prime means not number 2. That means number 1, number 3, number 4, number 5, number 6. 1 and 1. What is 1 and 1? Okay, 1 and 1. Teacher don't understand what is 1 and 1. Okay. Now let's look at the second toss. Okay. For the second toss, okay, right here, second. So we can also get number 2 or we don't get the number 2. 1 plus 1. Mm-hmm. What? Oh, what do you mean 1 plus 1? Am I missing out anything here? 1 plus 1. Okay, let's see what Kirtana has to say. 1 plus 1. To get 2. 1 plus 1 to get 2. Oh, no, no, no. Uh, oh, no, that's not what it means. It means that, okay, when you throw the dice, you want to get number 2. Straight away just the number 2. That means you don't include 1 plus 1 or no, tak ada. Cannot like that. We just want the number 2 only. Okay, so we won't get, don't take the 1 plus 1 or other than that. Just the number 2. Okay. Thank God you clarified that. Okay. So, okay, the first one we get number 2. Okay, here the first. Or maybe you don't get number 2. If I don't get, teacher write as 2 prime. 2 prime is easier lah. I don't want to write panjang-panjang, like maybe 1, 3, 4, 5 or 6. I don't write panjang-panjang. So you just write 2 prime. Prime is like all these numbers 1, 3, 4, 5, 6. Okay. The second time you toss also, you can get number 2 or you can get 2 prime. Okay. The bottom one, same. You can get number 2 or when you toss, you get 2 prime. That means not number 2. Okay, so far following up. Okay, now let's try the sample space. Sometimes another word for sample space is the outcome. Okay, remember sample space or the outcome. So here you have number 2 and number 2 coming out. Okay, second one. Number 2 and 2 prime. Okay, third one. 2 prime and number 2. The fourth one, 2 prime, 2 prime. Okay, done. So this shows Okay, this is your tree diagram. This already shows a nice layout. Okay, like first time you do, you toss what you get. Second time you toss what you get. Okay, can now let's maybe some students can ask teacher, why not you put 1 2 3 4 5 6, why did you put 2 and 2 prime like that? Because tree diagram usually, okay, we try to do the minimum branches, means like 2 branches only, try to go for the minimum one. Unless memang cannot, like tak boleh, you have to do 6 values for the dice, then you open 6 branches. Tapi dekat sini we can make it simplified, so we simplify and we do 2 like that. Okay. Okay, B, yeah. Okay, B, list all the possible values of x. Okay, let's list down all the possible values of x. Okay, what do we have for x? Okay, here are the outcomes, isn't it? So if you remember this now, beside the outcome, teacher wrote the x. So the x was getting number 2, correct? Getting number 2. So here we got 2 number 2s. Here we got 1. Here we got 1. Here we got 0. Okay, so your outcomes are, you can write down here, x equals to 0, 1, and 2. You don't have to use set notation because they did not mention. So we just list down only the possible values. Okay, C. This is the interesting one. Okay. List the probability distribution for all the possible values of x. Okay. Probability distribution. Okay, let's list. This one means you all must do a table for this. Okay, see this word, take note. Whenever you see list the probability distribution, that means you must do a table. Okay, how the format of the table is going to be, I'm going to show right now. Okay, let's start. We do the counting at the side. Okay, but teacher do the table first. Okay, total got how many x here? Got 3x, isn't it? Okay, so you do what? Here you write x equals to r. So you write these values for 0, 1, and 2. So that means you build your table according to how many x you got. You got 5x means, so you must do 5 columns and rows lah. Okay. The bottom one is to find the probability. Okay. The up one is the value of the x, how many x. Okay. The bottom is to find the probability. Okay, let's do the probability working at the side. Okay. Okay, for the 0, okay, probability x equals to 0. This r means is representing that numbers 0, 1, and 2. Okay. 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 We are going to calculate. Okay, for 0 means not 2 and not 2, isn't it? Okay. How to calculate? We need to know the probability what. Okay, for example, teacher, okay, I pergi ke tepi sekejap for a while. Okay, if teacher asks what is the probability to get a head in a coin? Okay, coin got 2 sides, isn't it? Got heads, got tail. So what is the probability of getting head? 1 over 2. What is the probability of getting tails? 1 over 2. So you know the probability. Probability always in pecahan form, fraction. Okay, so now here also let's write the pecahan, the probability first. Okay, what is the probability of getting number 2? Okay, 1, isn't it? Because number 2 got 1 number 2 only. But what is the total numbers in a dice? 6. So we write 1 over 6. Okay, this one 1 over 6. Okay, following up. Okay, next. What is the probability of getting not number 2? Okay, usually not means the balance, right? Okay, if you count here 1, 2, 3, 4, 5. So you can write 5 over 6. But usually, to get the opposite, what you do is you take 1 minus 1 over 6. You will get this value 5 over 6. Okay, usually. Following up. Okay, teacher repeat one more time. The first one you calculate first. This is 1 over 6, the probability, because the number 2 got one number 2 only. Total got 6 numbers, so 1 over 6. So what is the balance? The balance is 5 1. So 5 over 6. If sometimes like you're not sure how to get, you keliru with what number? You take 1 minus 1 over 6. So you will get this 5 over 6. Okay, this is the formula. Alright. Next one. Here to get the number 2 also is 1 over 6. This one to not get the number 2, 5 over 6. Okay, this one 1 over 6. This one 5 over 6. Okay, so this one you just write and keep the probability there, because now we're going to do the calculation. Okay, the first one. P probability for 0. 0 means 2 prime and 2 prime. Okay, what's the probability to get 2 prime? So we see here 5 over 6. So we write 5 over 6 times. Okay, because this one is like this, probability of 2 prime and 2 prime. So 2 prime is 5 over 6. Another 2 prime, 5 over 6 also. So 5 over 6 times 5 over 6. Okay, so here we will get 25 over 6. Sorry, 25 over 36. Okay, 25 over 36. So in this case, the first answer you can write the probability already, 25 over 36. That means the probability to get number 2 0 times. That means tak dapat number 2 langsung. Never get at all. The probability is 25 over 36. Okay, now the next one. Let's calculate probability to get one time. That means the number 2 can come one time only. Okay, so what probabilities we have here? We have this one and this one, correct? Okay, so you copy that one first. 2 and 2 prime, or this one, 2 prime and 2. Okay, so this is or means plus. What it means here again means I can either get this one or I can get this one. Okay, either one, right? So because of either one, this is a plus. So therefore, to get the 2, what is the probability of getting 2? So you see the first one, 1 over 6. Okay, so 1 over 6 times the probability of not getting 2, 5 over 6. Okay, so you just copy from here. For this one, okay, this one, teacher is taking the 2, right? 2, you take this, 1 over 6. 1 over 6 times not getting 2. Not getting 2 is this one, 5 over 6. So you times with 5 over 6. Okay, so 1 over 6 times 5 over 6 plus, okay, the other side, 2 prime. So that means that is 5 over 6 times with 2. 2 is 1 over 6. So we'll get the answer here, 5 over 36 plus 5 over 36. Okay, 5 over 80. Okay. Yeah, teacher's getting 5 over 80. So, here I can write 5 over 80. Okay, now the last one. What is the probability of getting the number 2 2 times? Because x equals to 2. So, for 2 times, we follow this. This first one. This is the one 2 times, right? Number 2, number 2. Okay, so take the values here. Number 2, 1 over 6 times 1 over 6. Okay. So, This one will be probability of getting number 2 and number 2. So 1 over 6 times 1 over 6, which is 1 over 36. So your probability distribution table completed already. You have all the values. Okay, teacher just make it smaller so you all can like copy first. Okay. This type of question got some marks, extra mark, which is like 5 marks when you do the probability, the table and everything. Okay. Okay, so far, any question? So far all clear, right? In order to do the probability distribution table. Okay, as long you remember the format. Okay, the format is at the top you write all the x. At the bottom you find the probability values. That's all. Okay. Okay, Kirtana. Okay, the last one, which is D. Okay, so today teacher will stop until here because the last example, right? Okay, the one teacher want you all to try this, not this one. Sorry, this one. Okay, this one teacher want you all try, but next week, next class teacher will show how to do this. Okay, let's look at D. Yeah. Okay, D is my favorite question. Hence, draw a graph for the probability distribution. Okay, do you all have a graph paper or not? If you have, can you bring your graph paper together? Now, teacher show using graph paper, then only you all will understand better. Okay, let me include my graph paper here. Because this one you have to draw using graph paper. Okay. Wait, let me include my graph paper here. Missing really. Uh, okay, my graph paper. Okay, I had the green color one. Now it's orange color. Okay, never mind. Okay, take your graph paper. Bring your graph paper. Okay, let me insert my graph paper here. Okay, can you all see my graph paper? Okay, I am going to make my graph bigger. So I'm going to cover the working for a while. Okay. Now, okay, let's look at how to draw, because how to draw the graph, very easy, the graph. Okay, all you need is graph paper, ruler. Drawing graph, always use pencil. Okay, always use pencil. Okay, now let's start with, okay, we draw the x-axis and the y-axis first. Okay, draw the x-axis. Okay, and we draw the y-axis, x and y. Okay, done. Let me just make it straight. Okay. Next, usually at the bottom here, okay, at the bottom here, this will be, you just copy x equals to r. Where do I take that from? You take from here, x equals to r. Okay, for the y-axis is the probability. So you just copy like whatever you did from the table. Okay, that's all. Okay, now what are the values we have here for x? 0, 1 and 2, isn't it? Okay, so my suggestion is, let's use 1 unit, okay, the scale. So the scale usually they will give, but this time they didn't give, so teacher give you all the scale. Um, 1 unit, 1 unit to 1 cm to 1 unit, sorry. 1 cm to 1 unit. Okay, this is for x-axis. Okay, x. For the y-axis, 0.4, 0.246. Okay, 2 cm to 0.2 units. Okay. Okay, what does this mean? What does it mean, teacher? Okay, the first one for the x, let's look at x. 1 cm. Okay, if you take your ruler, can you calculate 1 cm is should be here, like the 10 boxes. Okay, so here you write 1, then here we write 2, here we write 3. Usually you can stop until 3. You don't have to continue because your diagram, the what is that? The working that you did also until 3 only, right? X equals 3. Okay, this one we have to use 2 cm. 2 cm is 20 boxes. Okay, up to 20 boxes. Just check, just double check whether it's correct or not with your graph. 1 cm, how many box? 2 cm, how many box? Okay, I think 2 cm is the boxes here. Okay, so here is 0.2, okay, 0.4, then go up 0.6. Okay, I think I need to increase one more here. Let me increase my graph. I think I need until 0.8. If you don't have the spacing, just tarik a little bit more up. Or if it's too high yours, put your graph down a little bit. Okay, so the up here I just add 0.8. Okay, probability x equals r. Okay, done. Now let's look back at our just now the values. Okay, 25 over 36, the value is in decimal 0.694. Okay, 5 over 18, the value is 0.2778. Okay, 1 over 36 in decimal is 0.027. Okay, so we use these values, right? We use these values. Oh, sorry, by the way, this one, this 0 belongs to the y-axis. For the x-axis, you need to start another 0. Okay, so there will be 2 zeros here. For the y-axis, there's 1 0. For the x-axis, you erase and add one more 0 at the bottom there. This is the format. Okay, memang for the x, you must add 1 0 there. Okay, now let's start with this first one. 0 and what is this one? 0, 0.694. Okay, let's find where is 0.694. Okay, 0.69. Okay, here is 0.7, right, in the middle. So 0.69 should be somewhere here. Okay, the moment you mark already, you draw a straight line. Just draw one long straight line. Okay, let me use different color. Make it thicker. Wait, okay, draw one straight line touching that particular point, like that. Okay. So your probability graphs are straight line graph. You don't have to do a curve or like, curve or what is that? The shape, the one with the shape. No, it's just a straight line. Okay, the second one, teacher going to find for 1. Oh, I'm so sorry. I'm supposed to do it for 0, right? Sorry, here my graph, I'm zooming and unzooming, so I got confused here. Okay, it was supposed to be here. Sorry, that was for 0. All right, that was for 0. Okay, so we draw again the straight line. Right? Okay, here. Okay, touching here. Okay, done. Now only I'm going to do for 1. Okay, 1 is 0.2778. Okay, let me find where is 0.2778. 2.3 here. Then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, so it's somewhere here. Okay, sometimes you can't get exactly, so you put in between. Okay, we just put in between. Okay, now let me draw a straight line from the bottom here touching the top here. Okay, so done ready for the first 0 and 1 done ready. Okay, the last one for 2. For 2, I must put 0.02. 0.02 is going to be very small. Um, this is 0.1, right? Okay, 0.1, 0.02. Okay, it's extremely small. 0.02 is somewhere here. Okay, 0.027. Okay, it's extremely small because the number is 0.02. So therefore, okay, I draw a straight line. It's very short. Oops. Okay. Let me bring the line straight. Okay. So small. Okay, super small straight line. Okay. Now, once you are done, so consider this is your probability distribution graph. Your graphs are the straight line graphs. Okay. Oh, so small the last one. So usually it's like if in your paper, I think it'll be super like a bit only. Okay. Uh, so the main one, okay, what we learned today, the main one that teacher want you all to really understand, do practice back is your tree diagram. How to write the outcome, how to do the probability distribution table. The table format is always the same. Okay, always the same no matter what. The graph is also always the same type of graph, straight line. Okay, if you all did the graph together, just like send teacher or just tag teacher in Instagram so I can see how you all did the graph. Okay, so for like next example, teacher want you all to try. It's the same type of question. Okay, teacher want you all to try, and next class we will discuss the next example. Okay, so we shall stop until here. All right, if you all are right doing the graph, any question to ask before we end today's lesson? Okay, okay, sure. Okay, so all the best for your exams. If you all, some of you all are already going to start your exam, right? End of the August. All the best. Keep studying your maths well. Keep sharing teachers YouTube to all your friends. Okay, do ask them also to join the classes. So I'll see you all next week. Have a great week. Stay safe. Okay, bye, good night, take care. Well, I actually like the graph paper color for this time. Okay, okay, bye.